Good day to all of you. And today we are discussing the SLMC number 11 of 2023. And you will see some of these questions are actually quite similar to what we have in SLMC SLMC 2023. So some of these questions I will browse through, but I will still kind of give an explanation so that you can still get it. Okay. But if there's any doubt, I have discussed this SLMC 2023 in a separate video, so you can have a look at that. Okay, right. So let's dive in straight. I will discuss the first 10 questions, which are the easy questions. So the first one right here is a prime number is a whole number bigger than 1, which can only be divided by 1 and the number itself without the remainder. So we know that things like 2, 3, 5, 7 are primes. And then things like 4, 6, these are not primes. Which of the following is not a prime number? Now, again, the correct way of doing it will be just dividing all the numbers and see whether they have a um, factors. Okay, so however you look at it, it's an easy question. So always keep in mind, where does the question appear? If the question appears in 1 through 10, things might be easier than you think. So right here, I can see a number with a pattern that is 1, 3, 1, 3. Now I can immediately see that 1313 is 13 times 100. That would be 1300 plus 13. And you can see here, you can take 13 as a factor. And that gives you 13 times 101. And that implies this number is not a prime number. So just look at the peculiar number with the pattern, and then this might give you a composite number. Okay. Let's move on to the next one. A farm has a total of 25 chicken and rabbits. Their legs add up to 86. How many chickens are there in the farm? Now you can use what do you call this simultaneous equations to solve this problem. But if I encounter one of these problems, this is what I would do. Okay, it might not be the most efficient way. So in the comments, let me know, there might be even better ways. So 25 chickens and rabbits. So in total, you have 25. I will do this calculation in my mind. That is, if you have 25 chickens, you will have 50 legs. Okay. So that would be the least number of legs you can have, unless someone has eaten one leg of a chicken. But anyway, let's go up to the largest number of legs that you have. That would be 25 rabbits. And in that case, you will have 100 legs. Okay. So in that case, you will have 0 chickens. So how do you get 86 legs? So whenever you remove a chicken and add a rabbit, you will get 2 more legs. Okay. So to get to 86, that would be 36 more legs, which means you will have to add 18 rabbits. And there will be 7 chickens in the farm. Okay, as you could see, that calculation can be done immediately in your head. Okay. And again, remember, as I always tell, mathematics Olympiad questions or SLMC questions are not questions based on theories. It is just questions that test your problem solving ability. And the way you solve the problem doesn't matter, as long as you come at the solution fast and efficiently. Right. The number 36 has the following property. 36 can be divided by its units digit. So that is 6. And you can see 36 divided by 6 is equal to 6 without a remainder. With the number 38, it doesn't work. Okay, you divide 38 by 8. This is not an integer. So how many numbers between 30 and 40? So obviously we will eliminate 30 because it would be dividing by 0. And then have 31, 32, 33, 34, 35, 36, 37, 38, 39. So those are the numbers that we have to check. And this is good because 31 is divisible by 1, 32 is divisible by 2, 33 is divisible by 3, 34 is not divisible by 4, 35 is good, 36 is good, 37, no, 38, no, 39, no. So you have 5 such numbers. Okay, let's go to the question number 3. The following figure gives a side view of a structure made of 32 small cubes of volume 1 centimeter squared. 1 milliliter of paint is needed to paint one face of a small cube. So you could see that it is 4 cubes wide, 4 cubes long, and it looks like 1, 2, 3, 4 cubes in height. Not centimeters, cubes. Okay. So underneath you will have 16 cubes. So you will have to paint including the bottom. Okay. How many milliliters of paint are needed to paint the structure including the bottom? Okay. So you'll have 16 cube on the top. Okay. And then of course, when you look at it from above, you will see it is still a square. So all these tops will add up to 16. Okay, so that would be 16 here. Okay, and then you count this side. How many cubes do you have? It's just a counting game. Okay, so 1 in the first row, 3 in the second row, and 4 in the third row, and 4 in the fourth row. So you have 12 from this side. And here, from this side, you have 1 in the first row, 2 in the second row, 3 in the third row, and 4 in the fourth row. So you have a total of 10. Okay, the only thing that you didn't count is these ones. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 18. So these are the numbers that you'll have to add. So that would be 12 plus 16, 28, 50, and then you'll have 76. Now, there's another way to look at it this way. Okay, another way is look at it that way, and you will see that it's the same number that you have here. That would be 12. And then when you look at it this way, again, you will see flat. It would be the same number that you have here. So that would be 10. So you didn't need that counting part at the last, what you did in the last part. You can just add, say, 10 and 12, because it's like the top view is the same as the bottom view. And then this side view is the same as this front view. And then this side view is the same as this side view. Okay. How many different numbers can be made by rearranging the digits in the number 1, 2, 3, 4? Okay, so you have, let's say it's a permutation combination question if you are familiar with that. But even if not, think of it as a set of choices that you have to put in a box. Now, first one, there are 4 numbers and you can put any of these numbers here. So there are a total of 4 choices. Okay. 4 choices that you can use. And then after you choose a number, in this box, there are only 3 numbers you can put. So there will be 3 choices here. And then there will be 2 choices, and you will have to put the remaining number here. So you're going to get a total of 4 times 3 times 2 times 1. That would be 24 numbers that you can make. And a nice question for you guys would be, follow-up question. What are all those 4 numbers? We'll see. Okay, right. Let's move on to the question number 6. Now, this one appeared, I mean, most of these next questions appeared on the SLMC 2023. So in that particular video, I might be doing a better explanation here because I want to go fast. When each of the digits 3, 4, 5, 6 is placed in a square below, the sum of two digits numbers is formed. What is the largest possible number? Okay, largest possible sum. So again, think of it like this. I want to optimize, so I want to maximize the sum, which would imply I would put the biggest numbers in the tens position. So I can put 5 here and 6 here. Doesn't matter which one I put. Okay, and then next one would be 4 here and 3 here. And then you add it up, you get 117. Now, again, another 2 valuable questions. Well, an easier question would be, what is the smallest possible sum? And the next one I will ask you guys is, what is the largest possible difference? So now how can you optimize it? Okay, think about it. It's a really good question to ponder on at this level. Okay. 7. The digit sum of a number is the sum of its digits. Okay, so we have like 56. The digit sum would be 5 plus 6. That's 11. Digit sum of a number is the sum of its digits. How many 2-digit numbers have the digit sum 6? So if it is 6, and if it's a 2-digit number, well, it should start from at least 1. You can't start from 0. So if it is 1 in the beginning, then you have to have 5, and that will be the only combination you get from 1 in the tens position. And then 2, 4, 3, 3, 4, 2, 5, 1. Did I miss anything? Yes, I did. 6, 0. So there are 6 of these numbers. And there's anything else I don't get. Okay. Anything else, I will not get a digit sum of 6. Question number 8. Manit is traveling from A town to B town and passes by 2 indicative signs along the road. Okay. So what I would do here is I would represent this whole scenario using a number line. This is a number line. Okay. And you can see here you have A town. Okay. So let's say this is 0. You can do it. Either one of them can be 0. I will just, for my convenience. So here it indicates I have a negative for distance to A town, because that direction I would say it's negative, and this direction I would say it's positive. So this representation can help you. B town would be in 9 kilometers. And here it says B town is 2 kilometers, which means this point should be 7 kilometers. And here this says A town is some kilometers away. And you can see that would be the distance between this and this. So what is the distance between -4 and 7? And that would be 7 minus -4. And whatever the number, you take the positive part, because it's a distance. And that would be 11 kilometers. Okay. So again, this question thing, wants you to kind of represent the question in terms of something that you know, that is the number line. Okay, let's move on. Two corners of a square piece of paper are folded into the middle of the square and the following pentagon is created. So originally you had something like this. Okay. And then if the area of the pentagon and square are consecutive whole numbers in centimeters squared. Okay, wait until we think more on this scenario. So you can see, even though you don't see it immediately, now these are all congruence triangles. Okay, you can prove the congruency, but right now that's that. And then you can see that there are 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8 pieces. But in the pentagon, you have 1, 2, 3, 4, 5, 6 pieces. So the area of the pentagon to the square is going to be in a ratio of 8 to 6. Now we need to find the number which are, now find two numbers which are in the ratio of 8 to 6, but are consecutive whole numbers, consecutive, and that would be 4 to 3. And the area of the pentagon in this sense would be 3. And the answer is 3. And let's move on to the final question of the easy set of questions. This one right here. A triangle ABC is equilateral. So it has similar sides, same sides, and has area 27 centimeters squared. The dividing lines are parallel to the sides and divide the sides into 3 equal lengths. What is the area of the unshaded part? Now, because everything is symmetric inside an equilateral triangle, if you draw these 1, 2, 3, you can see all these triangles are congruent. And then there are 9 such triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then out of them, 3 are unshaded. So 3 out of 9 are unshaded. And the total area is 27. So you get 9 centimeters squared is the area of the unshaded part. Okay, I hope you enjoyed this session right here. And in the next video, we will see you with the somewhat harder questions. Thank you so much for watching.